Alright, so in this project of mine, I'm going to go ahead and explain to you how I coded a Rubik's Cube simulation that is able to scramble itself within 60 steps and unscramble itself within another 60 steps. So, just a heads up, the way that I kind of coded this project, I had it randomly scramble itself every single time it's run for 60 steps, and then it'll implement an algorithm that basically unscrambles itself by following the last step that it initially executed, and it works in the reverse order. So it'll execute every single step in the reverse order until the Rubik's Cube is solved. So that's the general gist of how this program works, and I'll just go through it and give you guys a brief description of what my code looks like and what you can kind of like alternate and adjust to play around with the simulation even more. So before I start explaining the code, there's just something you need to know about the IDE that I'm using. So the IDE that I'm using is called processing, and I'll link the download link in the description below this video. Processing, or also known as the Processing Development Environment, is an open source graphical library, and it's an integrated development environment, or IDE, that's built for electronic arts, new media art, and visual design communities with the purpose to teach non-programmers how to simulate certain programs while they are able to implement the back end of the code. So the cool thing is processing has a lot of integrated, I believe, JavaScript functions that kind of develops the simulation for you. You just have to call those functions, import it, and then also play around with it to get the simulation of the cube to work. So the first thing you want to make sure is you just import the PZCam library to the project, and this library just supports the fluent mouse camera interaction. So when you're holding and dragging the cube around, you could see all three dimensions. After that, you just want to make sure that basically you create a dimensions variable that stores how many dimensions there are, a speed variable. You can adjust the speed variable to even higher, 0.3, 0.4, 0.5. It depends on how fast you want to see the simulation execute. That's totally up to you. Then here we just have an array which stores the three dimensions of the cube. Moving forward, these are just basically all the possible moves that can be made on the cube, and I store that in another array called all moves. The array list that I created here called sequence stores the sequence of moves that's been instructed for the cube to execute. I have a counter to count the total number of steps taken when scrambling and unscrambling the cube. And then I just have a couple of variables to make sure that it's basically checking whether the program has started or not started. And you can check whether the program has started by programming it when to start. So for instance, if you go into the controls file, I programmed my cube to start scrambling and unscrambling as soon as the user inputs S on the keyboard, the lowercase letter S. You can go ahead and change this to make it a space by deleting S and keeping a space, so that way when you click the space bar, the cube can execute, or any other key to get it started. But since S starts with start, I thought that would work best. Anyways, moving forward, you can see that I created a void setup function. What this basically does, it just sets up the dimensions of the cube itself. You can see that I used a triple nested for loop as you were working with 3 dimensions. Within this for loop right here, you can set the number of moves you want the cube to execute. So I set it to complete 120 moves. So out of those 120 moves, it's going to scramble for 60 moves, and then it'll unscramble for the remaining 60 moves. Basically, you want to keep in mind that since your index is originally starting at 0, it starts scrambling at the 0th step, and it'll finish at the 119th step. So that's what that for loop is responsible for. In the next for loop, you can go ahead and see the total. You can get the total number of moves in a sequence, and you store that within the variable called current move. I'll let you guys kind of play around and understand the programming itself. I left a lot of comments to explain it even more, and you can look at it over my GitHub. It is open source. The hardest part, I would say, is getting the rotations to work. You need to make sure that you truly do understand matrix math and linear algebra. just to make sure that you can program these turn Z, turn Y, and turn X functions to work properly. I created these three functions because we are rotating the cube with respect to the three different dimensions, so the X, Y, and Z axes. And you can just go ahead and walk through that a little bit. It's not too hard once you notice. You'll just see that it's just working with a bunch of matrices. And then finally, we want to set up the environment of the cube within the video, so you can use the draw function, and that just basically sets it up by showing what the counter will count to. This is just the size of the text. Here I'm basically just performing the sequence of rotations after the spacebar, or originally I programmed the spacebar to start the program, but in this case it's S. That will just execute that step. Scale is just to make sure it scales the cube in the center of the window. If you don't scale it, it'll scale very weirdly, and you won't be able to really see the cube. And here I'm just determining what the orientation is and checking what the cube needs to be oriented on a specific axis. So whether it's the Z, X, or Y axis, how should it rotate? In the next file, so I already explained controls. In the QB file represents how to rotate each individual QB within the cube. So a QB is you can think about it as like the box within the overall cube. In this file, you could see all the faces and vectors that I created. Each face contains a different color. I programmed how you should rotate the QBs with respect to each axis based on their direction. It takes in the direction, and then it calls these turn functions, which will rotate the cube with respect to the axes. If you go into the face file basically represents like all the matrix transformations and rotations that you'll be performing. This is a little bit more complex. I would highly recommend you review some linear algebra concepts on translations and rotations before attacking this file. There are also a lot of good YouTube videos online that explains this program. I'll go ahead and set a link to a description if you want a more in-depth explanation of what this file does. It's nice because when I was working through the tutorials, the instructor who taught me how to do this really provided an in-depth analysis of the translations and how to rotate with respect to each axis. The final file that I have programmed is the move file, and within this move file it basically takes into account the angle that you're rotating at, the X, Y, and Z axes, and the direction that you're rotating at. It also keeps in mind the animation, so it won't the animation won't begin until you press the S key on the keyboard. So I created a move constructor here, which takes in the coordinates and the direction as the parameters. Just kind of sets up how move should really execute. Here I have a copy function, which basically returns the current new object and the current object, which will be used a lot more in the Rubik's Cube, as you see when you're playing around with it. The reverse function, all this does is when it's called, it reverses the function of the rotations performed, and all you have to do is just increment it or multiply by -1. That's it. And then the start function. The start function is what's responsible for beginning the animation itself. Created a Boolean function called finished, which just tells the program when all of the instructions or in this sequence have been performed. Update basically updates the cube and just tells when an instruction has been performed and what kind of instruction has to be performed next after with respect to the axes that it is on. So in the next part of this video, you'll see the actual simulation. All you have to do is click the run button, and once you click the run button, the simulation will pop up in the full screen because we programmed it to show up within the full screen. And yeah, that should be it. Alright, so now that I've explained the code, I'll go ahead and simulate the program for you guys. Just a heads up, you should first see a two-dimensional square, but the nice thing is that it's actually gonna, if you just hold the center and click and drag, you can see all 3 dimensions, and we have a counter right here. That counter that I talked about in the code that increments to show the number of steps. So it's supposed to scramble the cube within 60 steps, and then it should unscramble it within another 60 steps. It starts counting from 0, so it should execute a total of 120 steps, but since it starts counting from 0, it should stop at 119. So to run the program, all you have to do is click the start button, which is S in this case on the keyboard, and it'll begin. And the cool thing is you can go ahead and rotate it in any type of orientation that you want. It just looks really cool. And you can see that number constantly just increasing, and it should stop at 119. There you go, 119. And now you'll see the completed Rubik's Cube. That's it. Thank you for watching.